Today's lesson is on section 5.6, fit align to data. When we're talking about fitting a line to data, we're going to be talking about scatter plots, which is one set of data that, as I tell students, they should definitely know how to analyze and find a pattern in. Data is all around them. Many of them will find themselves, I'm sure, in the future in jobs where somebody will hand them some data and they'll be expected to interpret it or just find a pattern in it or use it to make their next decision for their job. So, and scatterplot is one of those types where I think it's something they should have the ability to read at this age. Also, scatterplots are going to be on the MCA, as I tell them too. We know that for sure. That's a topic they always talk about. So something that we need to know about. What is a scatterplot? Well, just as an old example, here's in red is what I want you to write down if you're taking notes along with me. There's a scatter plot, a graph used to determine whether there is a relationship or trend between paired data. And don't let that phrase paired data scare you. That's just like an ordered pair, like an x coordinate and a y coordinate. Or like, for example, 2 comma 3. Okay, so paired data is just saying numbers that go together like an ordered pair. Here's what a scatter plot would look like. There's like an example. Again, we'll have some kind of graph, and we'll plot, our ordered pairs, just like going over so much for the x-coordinate, up so much for the y-coordinate. And it might look something, again, like this, like I have a little example there. So maybe copy that next to your scatter plot definition as well, just as a reminder of here's what a scatter plot looks like. And again, what are we going to be doing with scatter plots, or what are you often looking to do with scatter plots, is find some kind of pattern in it. Okay, either the data shows that, as one thing goes up, another thing goes up, or as one thing goes down, another thing goes down, or I'll talk about that on the next few pages here, but we're looking for some kind of pattern, some kind of, as it says here, relationship or trend. We're looking for a pattern. That's why we analyze scatter plots. When we're doing this, we use something called a line of best fit to really highlight whatever the pattern is in that scatter plot. Line of best fit, a line used to model the trend in data having a positive or negative correlation. So what it's, again, like I kind of described there, it's really trying to show us here's what the pattern is. Here's what's happening in this scatter plot. So I'm going to draw it in blue here on my little example. Here's what a line of best fit might look like on a scatter plot. It's trying to follow the pattern of the data and show here's where the data is going. And also, usually it tries to divide the data about in half, so let's say it might look something like this. Okay, my blue line there. Okay, there's a line of best fit. You kind of cut the data in half, but more importantly, it kind of shows that, if this data continued, if our trend continues, here's where the data is going, out that direction. Okay, but again, we'll show some more of these as well as we get into the next few pages. So just below those definitions here, I've got an example of some kind of data you might plot with a scatter plot, and then try to find some kind of pattern or some kind of relationship with it. What I've got is, as it says here in the title, number of wins in different years for a baseball team since 2000. So it says here in 2001, here's how many wins they had, in 2002, 2003, and so notice it tells how many wins there are, so it's kind of like paired data. Here's the year they're talking about, and here's how many wins they got that year. So that's what we're calling paired data, just like ordered pairs. So what I'm going to do is I'm going to make a scatter plot of this table. I'm going to plot each one of these points. So let's say like 2001, 14. Okay. I'm going to go here along the bottom where it says 2001 and go up to 14 and just put a point right there. Okay. 2002, 15. And again, this is just like plotting ordered pairs like we've done many times this year. 2003, 14. So this will be at least kind of a review or something that we definitely should know how to do. This is nothing different so far for students. 2004, 12. 2005, 10. 2006, they also had 10 wins. 2007, they had 9 wins. And 2008, they had 7 wins. So there's my scatter plot for this paired set of data, or paired data. And so now what I'm looking for is some kind of pattern. Is there a pattern in this data? Yes, there is, I think. It looks like, well, as the years went on, things got bad for the baseball team, I guess. So they weren't winning quite as many games as they went from 2000 all the way up to 2008 here. So yes, I see there is some kind of pattern. It looks like the wins are decreasing as time goes on, as the years are going up. It looks like the pattern is, well, the wins are going down. Not so good. Not so good for the team. Okay. If I was going to make a line of best fit for this data, here's what it might look like. And again, I'll talk more about this soon, but here's what it might look like. Again, something that kind of follows the pattern of the data. It also kind of splits it in half, so maybe I have about the same number on top and bottom. So, but there's what it might look like. We'll do a little bit more on this again on the next few pages, but there's an example. Here's what a line of best fit is supposed to do. It should highlight what's the pattern of the data. Where's the data going? What I'll tell students sometimes, this is, it seems like a kind of a small tip, but might help them, is when they're doing these problems too, they should kind of, as they're trying to find the pattern, maybe trace the data and see what the pattern is just with your finger, like where's the data going? So they kind of take their finger and trace, okay, here's all the points, and they can't kind of see, just like my blue line, that's kind of where it's going. They trace it like this. And that may just kind of, it seems like a simple thing, but it may kind of help them realize, okay, this is where the pattern is going. That's what my line should look like as well. So there's drawing a line of best fit for that scatter plot. Now when it comes to analyzing a scatter plot, the previous page on that definition we wrote down, it says that we're looking for a trend in the data having a positive or negative correlation. So what do these things look like, a positive or a negative correlation? Going to this page. Well, data can either have one of those two things, and what's nice is that just like we've talked about with slope and what types of slope there are, like positive and negative slope, positive and negative correlation go along with what these look like. Like this very first one here. This first set of data we're talking about has a positive correlation. What happens when there's a positive correlation, as I've got written down here, as whatever your x values increase, whatever those are, the y values also are going to increase. So kind of like I wrote on that previous one, I kind of showed the arrows, but here, this is the positive correlation. As whatever, like let's say this is time, as time goes on, okay, let's say this is your bank account. You're saving more money, you're making more money, okay? As one thing goes up, the other thing goes up. We call that a positive correlation. And here's what it looks like when you see that in data, okay? It's going up and to the right, just like positive slope lines, okay? If I made a line of best fit for this, what do you know? It'd be a positive slope line for that positive correlation. So again, that should match up. That's kind of one nice thing with correlation is it won't be too far away or different from what we've learned about slope as well. So if that's positive correlation, then obviously this middle one must be negative correlation. As one thing increases, as my x values increase, my y values actually decrease. So here's what it looks like in a scatter plot. And again, there's what a line might look like. A line of best fit might have. It'll have some kind of negative slope, some kind of negative correlation to it. An example I might give for this one is, maybe the more time a student spends watching TV, as time goes on, they're watching more TV, probably the less homework they're getting done. Okay, so there's something with a negative correlation. Two things that we paired together would probably have a negative correlation. As one of those things goes up, the other one's probably going down. So the more TV you watch, the less homework you're getting done. That's a negative correlation. One thing goes up, the other thing goes down. Okay. And then we can have this as well, as you can see here. There can be no correlation, no visible pattern, as I've got written here in red. No visible pattern as x increases. I do want you to write down each of these three graphs and then the little red phrase below here with it, because that's what's describing it, what's happening. But there can be something with no correlation, so something that has no pattern as time goes on. As time goes on, that maybe it could be something. It could be, I guess, anything. Maybe like the number of rainy days there are each year. Okay, I mean, as time, every year there's a different number of different amounts of precipitation, different amounts of rain. I mean, for any given year. So it doesn't necessarily mean like, oh, the more time goes on, the more rain we get. Okay, or the more as time goes on, the less rain we get. It could just be all over the map in terms of how much we get each given year. So there's not necessarily a pattern for that. As time goes on, can't tell you it's gonna be more or less rain. There's no pattern showing that. So. But there are the three types of correlation that we're going to talk about: positive, negative, or no pattern, no correlation. On this page, I'm going to talk a little bit more about drawing your lines of best fit. And again, up here I've got 2 bullet points, and these are kind of showing the 2 main things that you need to do when you draw a line of best fit. What should happen? And they are actually in order of kind of like prioritized. Okay, the number one thing you need to do. I actually label these with a 1 and a 2. That's really how you should label these. The number one thing you should do when you're drawing a line of best fit is you need to follow the pattern of the data. The line of best fit is something we're going to use to make a prediction for, okay, what's going to happen in the future. Okay? Or what's going to, what happens maybe in this middle section of the data where we don't have much information. Can we make some guesses about that? A line of best fit highlights the pattern and should kind of show the trend and show us what's going to happen, before or after, maybe in between the data. So if you go to a set of data, and again, number 2 says split the data in half, so that's good. That is something you also want to do. But I see sometimes too many students concentrate on number 2 as opposed to number 1 here. They try to split the data in half, and I've seen people draw lines of best fit like this. Okay. So looking at this blue line, this is incorrect. Do not do that. Okay, that is not right at all. Yes, you split the data in half. Maybe there's about six dots on each side. Okay, and that's a good thing. But number one thing is you need to follow the pattern. Okay, if you don't do that, then what we've tried to accomplish for this scatter plot is lost. Okay, it's out the door. Like for a scatter plot, you're trying to find some kind of pattern in it. That's what you're doing with a scatter plot. We're showing the data so we can see, is there a trend? Is there a relationship? So for this case, this first one looks like it's going down to the right. It looks like a negative correlation. So again, like I suggested earlier, maybe a good trick for some students is make sure they kind of trace the points a little bit with their finger and say, okay, well, here's where the data is going. This is the pattern of the data. So their line should also look something like this. Okay, some kind of negative correlation. And yes, you want to split the points in half. Okay, that is a good thing. But number 1 is you gotta follow the pattern first. You have to. Okay, otherwise it's not going to be a good line of best fit. Go into this next one here. Okay, I'll just kind of show again what some lines of best fit might look like. This one looks like it's got a positive correlation. Looks like it's kind of going up and to the right. So I might maybe draw a line something like this. Okay, did I split the data exactly in half? Well, it looks like I'm pretty close. Like if I look on this side here, I got 1, 2, 3, 4, 5, 6. On the other side, I got 1, 2, 3, 4, 5, 6, 7, 8. So, I mean, I'm close. And again, that's the most important thing. You should be close. If you don't split it exactly in half, that's not the worst thing. But I'm more worried about, let's just make sure we follow the pattern of the data. That needs to be the priority when you're drawing a line of best fit. Okay. For this third one here, I don't see any kind of pattern going on there. Again, as one thing's happening, okay, as we're going farther and farther down the x-axis, okay, my points don't look like they seem like they're going up or down. It doesn't seem like they have any kind of pattern to them, really. Okay, so this would be, I think, a classic case of no correlation. So I just write that. I don't have to make some kind of line or anything because there isn't a pattern. The line is supposed to show some kind of pattern, like it says in number 1. So if there isn't a pattern, I'm just not going to draw a line of best fit. I'm just going to write no correlation. I show this next one up here just so students know that there are different types of correlation as well. There's positive and negative, or there's different types of patterns, I should say. Okay, there can be curved patterns. This could be something that they might see. A pattern like this might be, the months of the year. The months of the year, like January, February, March, April, May, so on. And it might be, whatever the average temperature is. Okay, in those months. Okay, you could definitely see a data chart like that where obviously it's colder here in January and December, the months at the end. But at the top here, the hottest days are of course in summer, in June, July, August. So again, just showing that you could see there are definitely plenty of other types of scatter plots and plenty of type of patterns that they're going to see. We're going to focus mainly on positive, negative, and no correlation, but there are other ones as well, so I just put that one on there to show that. Okay. And then looking at these last two, again, if I'm drawing a line of best fit, this one looks like a positive correlation. When students are doing this, they will use a ruler because they want to draw a nice straight line, because the other thing we're going to do with this is make some equation for our line. So, but they'll draw a nice straight line. Again, one thing is follow the pattern of the data, and if they split it exactly in half, that's good too. But that's kind of a nice thing that you can also try to do as a rule of thumb, but definitely make sure we follow the pattern of the data. Okay. This last one looks like a negative correlation. Maybe something like that for my data. It's going looking down and to the right. If I kept going on, like I'm trying to make a prediction as the line goes on, where would the data go? It looks like it'd keep going down this direction if I just kept following the data. So that's what I want my line to do too. It highlights the pattern and shows where would the data keep going if it continued on. Well, then making a scatter plot and making our line of best fit, that's good. But one other thing we have to do with our line of best fit is we are going to make equations for those lines. And we've done plenty of this in class where we see some kind of line on a graph and then we make an equation for that line. What's the best form we know how to do this with? It's slope-intercept form. And that's where we're going to use again. So if I can make a line of best fit like I've got here on the graph, I can make an equation of that line. And then that could be something that could help me predict points in the future or other points in the data. So the line of best fit, the equation for it, can also be very helpful. Can we make a line of best fit, or can we make this equation again? Yeah, we should be able to. All we need to do is be able to figure out the slope of the line and the y-intercept of the line. Well, as I'll tell students, as we worked on in the past here, remember, if you have the graph of a line, one of the things you can pick out right away is the y-intercept, the b. Okay. Usually I try to find m and b for this when I'm making an equation in slope-intercept form. Again, the b should be a nice one you can find because it should be right where the line connects with the y-axis. So in this case, as long as I always make sure I draw my line to that point, or to the y-axis, I can always find my b. In this case, it looks like it's about 16. Okay. And if it was like 16.5 or something, I could put that, but we'll say it's right about on 16. So the b, the y-intercept, I don't have to do any work for that. I can just pick out where the line hits the y-axis, and that's good. There's my y-intercept. The slope, there's only one key thing about the slope, and I've got it kind of written in these directions up here. And if you're taking notes along with me, here's just kind of a step-by-step to kind of keep you going, just in case you have trouble getting these started or knowing what to do next. But number one, you're going to make your scatter plot. You're going to determine if there's a linear pattern for it, positive, negative, or no correlation. If there is a positive or negative, you're going to draw your line of best fit, just like we've done in the first couple examples here. And then the last step, the most important one to help make your equation, is you got to pick 2 points on the line of best fit that you've made. 2 points that are on the line. If you take 2 other points, like let's say you pick this point here and this point, okay, and you try to make an equation with that and finding the slope and the y-intercept, then what you've done is you've made the equation of a line that goes through those 2 points, like this. That's not the line of best fit that I have up here, though. So when you're doing this, you have to make sure you pick points that are actually on your line of best fit. And you can just kind of eyeball them, or maybe you actually go through points. But as I look at my graph here, let's see, I'll just kind of try to pick some out. It looks like here's a point right here, 14 in the year 2002. Okay, and maybe this isn't a point in the data, but I can see right on my line here, there's a point, 214. Let's kind of bring it down here. 2002, they had 14 wins, or they might not have actually had that, but again, that's a point that's on my line, and my line is showing the pattern, so I'm going to use that. So 214 is one of my points. And then looking for some other point here, looks like I have about, maybe about as I go down to right here, 5. In 2005, they had, let's say, about 10 wins. It looks like if I follow that over, that's pretty close. So 2005, and they had 10 wins. Okay, so there could be my 2 points. Well, again, if I have 2 points on my line, I can use that to find my slope. I just do my subtraction, subtract the y coordinates, subtract the x coordinates. 14 minus 10 over, in this case, 2 minus 5. 14 minus 10 gives me 4. 2 minus 5 gives me -3. So it'd be like -4/3 for my slope. And I said that my y-intercept was 16. So again, we can make an equation, -4/3 x plus 16. There's the equation for my line of best fit. Again, really looking at that, as students hopefully will recognize, did I really do anything making the line? Was that anything new that we haven't done in class? No, not really. Okay, I mean, if I can just pick 2 points on the line, We know we've done this tons of times. Okay, find the slope from those. Being able to find them by just doing the subtraction. Or again, even you could just count down and over, just like when we find the slope. You could say, well, it looks like I go, down 4 in terms of the wins and over 3 in terms of years. So negative 4/3 would be my slope. And then again, if I just keep following the line back to wherever my y-axis is, I can find my y-intercept and I can make my equation. Again, good practice of something we've done a bunch of times, and also will help us here making scatter plots and making lines of best fit.